Hello everyone, I'm Sudha Udaya. Welcome to today's unit in the Building and Construction program. Before we begin, I want to remind you of the purpose of this program. Each unit is designed to give you the knowledge, skills, and industry behaviours required to become a competent and confident building practitioner in Australia. Throughout this course, I'll be drawing on more than 30 years of hands-on experience in residential and commercial construction. My goal is to connect the theory directly to real project situations, showing you how the National Construction Code, Victorian regulations, WHS requirements, and industry standards apply on actual work sites. As we move through each topic, think about how these principles translate into the decisions builders and site managers make every day. By the end of each unit, you should feel more prepared to apply these concepts in practical, safe, and compliant ways on the job. Let's get started. And today, I'm going to walk you through the unit CPCCBC4012. Read and interpret plans and specifications. In this presentation, we will explore one of the most fundamental skill sets required in the building and construction sector: the ability to accurately interpret drawings, specifications, and supporting documentation. This skill underpins everything we do on site, from early cost planning and tendering, all the way through to construction supervision and compliance verification. By the end of this session, you will understand how plans are developed, how amendments are controlled, how to differentiate types of drawings, and how to read structural and non-structural details. You will also learn how to extract meaningful information from plans, so you can apply it confidently during real-world construction tasks. Unit objectives. This unit contains 4 major learning objectives. First, you will learn how to identify the different types of plans and confirm that the drawings and specifications you are working with represent the most current version. Second, you will learn how to read and interpret plans by understanding key features such as orientations, contours, building layouts, dimensions, and detailed drawings. Third, we will move into identifying structural details, such as concrete footings, slabs, reinforcement, load-bearing components, tie-down requirements, and wind bracing systems. Finally, we explore non-structural details: prime cost and provisional sum items, service installation points, fixtures, and finish schedules. These 4 objective areas give you the foundations to interpret any residential or small commercial building plan confidently and accurately. Introduction to construction plans. Before examining individual drawings, it is important to understand what building plans actually represent. Construction plans are visual documents that present a complete picture of the building. Instead of long written descriptions, plans use scaled drawings, symbols, legends, and notes to explain how a building is to be constructed. Plans show dimensions, locations of elements, materials, elevations, details, and installation requirements. They also convey structural systems, services, site conditions, and compliance conditions that must be met before construction begins. These drawings work together with the written specifications. Plans give the graphical information. Specifications explain the technical details that cannot be shown graphically. Both are legally binding contract documents, and both must always align. A misinterpreted plan can lead to incorrect ordering, non-compliant installations, unnecessary rework, or costly disputes. This is why reading plans accurately is one of your most essential professional skills. Confirming current versions of plans. A critical step before you begin reading any plan is to confirm that the drawings you are working with are indeed the latest approved version. Construction projects evolve. Clients change ideas, engineers adjust structural systems, and site conditions sometimes require redesign. These updates appear as amendments. To check for the most current version, go to the title block, usually located in the bottom right corner of the drawing. Look for the field labelled Date Drawn, Revision Number, or Issue Status. Then check the Amendments box, typically in the lower left corner. This table lists all revisions, their date, description, and initials of the drafter or approving engineer. Once you identify the most recent revision entry, confirm with the appropriate professional, such as the architect, structural engineer, or services engineer, that the plan incorporates all approved updates. Only after this confirmation should you begin using the plan for construction, costing, purchasing, or supervision tasks. Plans versus specifications. Plans and specifications work hand in hand. Plans show the visual representation of the building, the layout, elevations, sections, and structural elements. Specifications explain the items that cannot be expressed visually, such as concrete strength, installation tolerances, step-by-step procedures, finishes, and fixtures. Specifications may include strength grade of concrete and steel, brand names, colours, and model numbers, fixing methods and tolerances, qualification requirements for installers, safety procedures and compliance conditions. For a simple residential project, specifications may be only a few pages. A complex commercial project may have hundreds of pages. Your responsibility is to read both documents together. Anything unclear in the plan is usually clarified in the specification and vice versa. Both documents represent the legal contract between the builder and the client. Next, we explore the different types of plans you will encounter. Each plan has a specific purpose and provides different categories of information. Understanding which plan to consult is a fundamental skill. Common types include concept drawings, early sketches illustrating ideas, architectural plans, layouts, elevations, sections, openings, materials, structural plans, footings, slabs, beams, reinforcement, bracing, civil plans, levels, site works, drainage, external works, mechanical plans, HVAC systems, electrical plans, power, lighting, communications, plumbing and drainage plans, water supply and sewerage, utilities and services plans, gas, stormwater, meters, connections. Each drawing set contributes a critical piece to the overall construction process. Your task is to recognize what type of detail each plan provides, so you know where to find the information you need. CAD and BIM technology. Modern construction drawings are digitally developed using CAD and BIM systems. CAD, computer-aided design, provides precise 2D and 3D drawings that are easy to edit, share, scale and print. CAD allows layers to be switched, enabling you to isolate structural, architectural or service features. BIM, building information modeling, goes even further. BIM produces highly detailed 3D models that combine architectural, structural, mechanical, electrical, and plumbing services into one integrated file. This allows different professionals to collaborate in real time, detect clashes before construction, explore multiple design options, and better visualize the final building. Understanding CAD and BIM concepts will help you navigate modern plan sets and recognize how design information is coordinated. Architectural plans. Architectural plans describe how the building will look and function from a design perspective. These drawings include floor plans, the room layout, walls, windows, doors, stairs; elevations, the exterior appearance of each building face; sections, a slice view through the building; schedules, door schedule, window schedule, finish schedule; detailed drawings, joinery, cabinetry, wet areas. Architectural plans are your primary reference for understanding the internal layout and the aesthetic design of the building. They do not typically include structural sizing or reinforcement, but they coordinate closely with structural drawings. Structural plans. Structural drawings show the engineered elements that give the building its strength and stability. These include footing and slab plans, beam and column layouts, reinforcement detailing, retaining walls, bracing and tie-down systems. These drawings specify depths, diameters, bar spacing, load-bearing capacities, and structural material requirements. Whenever you need to know the thickness of a slab, the size of a footing, the spacing of reinforcement, or the type of bracing required, the structural plans are your primary reference. You must also verify that the structural details comply with the National Construction Code and applicable Australian standards. Site plan and building location. A site plan shows an overhead view of the entire property. This drawing includes the block number and street address, boundary setbacks, north point orientation, existing site features, trees, fences, driveways, contours, and reduced levels, sewer, power, and water connection points, the location of the proposed building within the boundary. Knowing how to read a site plan is crucial because it influences compliance, such as setback distances, drainage gradients, access routes, and construction staging. The title block will show the address. The drawing will show surrounding properties, access roads, and the exact orientation. A clear understanding of the site plan ensures that your construction activities occur in the right location and comply with planning requirements. Understanding site contours and levels. Site contours represent the shape and slope of the land. Each contour line corresponds to a specific elevation above a designated datum. Widely spaced contours indicate flat terrain. Closely spaced contours show steep ground. A uniform slope is indicated by evenly spaced lines, while irregular spacing shows uneven terrain. You will also encounter reduced levels, RLs, which express height relative to the site's datum. This information is critical when setting out the building, planning cut and fill works, positioning drainage systems, ensuring compliance with flood level requirements. Accurate interpretation ensures you avoid drainage issues, retaining wall failures and construction errors related to slope. Reading floor plans. A floor plan represents a horizontal slice of the building, typically cut at around 1 meter above floor level. Floor plans show room layouts and names, internal and external walls, door and window placements, stairs, cabinetry and fixtures, dimensions for walls, rooms, and structural elements, notes about materials and finishes. To interpret the floor plan accurately, identify the scale, refer to the legend, read the dimension strings, and understand the symbols used for doors, windows, plumbing fixtures, and electrical fittings. Floor plans form the foundation for supervising internal construction work, checking compliance with layout requirements, and guiding trades such as carpentry, plumbing, tiling, and electrical installation. Dimensions and scaling. Dimensions are one of the most important elements on a plan. They can be expressed in millimetres or metres, depending on the drawing. Key dimension types include overall building dimensions, internal room sizes, window and door openings, setback distances, structural spacing. Understanding how to scale drawings is also essential. Most plans are drawn at 1:100 or 1:50 scale, but detailed sections may be 1:20 or 1:10. Never assume, always check the scale noted in the title block. When using CAD drawings, you may rely on digital measurements, but printed plans must always be checked with a scale ruler. Accurate measurement ensures correct installation, ordering of materials, and verification of on-site workmanship. Detail drawings. Detail drawings provide enlarged views of specific areas where standard plan scale cannot show sufficient information. Details commonly include stair construction, wet area waterproofing, balustrades and handrails, window and door flashing, corners, junctions and connections, footing and slab cross-sections. A detailed drawing may include notes identifying materials, installation methods, fixings, membranes and tolerances. If you ever feel unsure about how something should be built, you should always check if there is a corresponding detailed drawing. If not, consult the architect or engineer before starting construction. Identifying structural details. Footings. Let's now examine how to identify structural details from the drawings. Footings are one of the core structural elements that transfer building loads down to the soil. To identify the size, depth, reinforcement and position of footings, refer to the footing plan and the footing schedule. Typical footing codes might be BP.1 or BP.2, where BP means board pier. The schedule will tell you the diameter, such as 450 millimeters, the reinforcement required, such as 5N12 vertical bars, and the spacing of ligatures, such as R6 helix at 200 millimeters pitch. This information must match the structural specifications document. Accurate understanding helps avoid foundation failures or non-compliance with engineering requirements. Slab details. Slab plans indicate where concrete slabs are placed, their thickness, joint locations and reinforcement. Slabs may be differentiated, such as a 125mm warehouse slab with SL72 mesh, or a 100mm office slab with SL62 mesh. Slab drawings are often supported by sections showing the layers, vapor barriers, hard core, reinforcement placement, and edge beams. Reading slab details is crucial for correct concrete ordering, setting out, and supervision during pouring and finishing. Load-bearing points. Load-bearing points refer to the locations where the building's weight is concentrated and transferred to the foundation. These points occur at columns, major beams, structural walls, or junctions. On structural drawings, they may appear as column markers such as C1. Once identified, ensure these align with footing placements. Load-bearing details may also be found in the specifications, for example, concrete strength grade, slump requirements, reinforcement anchorage, and minimum cover. Identifying load-bearing points ensures construction follows engineering intentions and maintains structural integrity. Bracing and tie-down requirements. Wind bracing and tie-down systems prevent the building from racking or lifting during strong wind loads. Bracing may include strap bracing, such as XB.1 or XB.3, installed at specified angles and spacing. Tie-downs include bolts, straps, steel plates and anchors designed to resist uplift forces. Roof framing plans typically include a bracing requirements table that specifies size, configuration, fixing points, and installation method. Without proper bracing and tie-down systems, the building becomes vulnerable to movement, structural failure, or safety risks. Non-structural details, PC and PS items. Non-structural details include prime cost, PC, and provisional sum, PS items. Prime cost items are allowances for fixtures or fittings whose exact price or brand is not known at contract signing, such as ovens, tiles, or tapware. Provisional sums refer to work items where the scope is not fully defined, such as excavation, landscaping, or repair works. These items may become sources of dispute if misinterpreted, so always refer to the contract section listing PC and PS inclusions. Accurate identification prevents miscommunication, cost blowouts, and contractual disagreements. Services, installation and connection points. Service details indicate where water, sewer, Electrical, gas, and communication systems enter and operate within the building. Installation points appear inside the building, such as plumbing fixtures, electrical outlets, smoke alarms, and HVAC units. Connection points appear outside the building, such as water meters, consumer power poles, sewer connection points, and gas meters. To locate these points, refer to the site plan and the plumbing, electrical, or services drawings. Correct interpretation ensures safe installation, compliance with utility authorities, and seamless coordination among trades. Fixtures and finishes. Fixtures refer to fixed items such as cabinetry, bathtubs, toilets, vanities, or built-in wardrobes. Their exact location, model, and installation requirements are shown in architectural plans and schedules. Finishes include paint colors, flooring materials, wall coverings, and joinery finishes. These are usually documented in the specifications or finish schedules. Accurate reading of fixture locations and finish specifications ensures the final product meets design expectations and prevents costly rework. This unit has covered a complete overview of how to read and interpret plans and specifications for building and construction projects. We discussed how to confirm current drawings, identify plan types, interpret architectural and structural details, understand service locations, and differentiate PC and PS items. These skills directly support safe, compliant, and efficient construction practices. As construction professionals, your ability to accurately interpret plans influences everything from cost estimation to on-site supervision and communication with trades, engineers, and clients. The more comfortable you become with these documents, the more confident and effective you will be in your construction career. Thank you for following along. I trust this video has provided the guidance you need to successfully complete your assessments. I'm Sudha Udaya, and I look forward to seeing you in the next lesson.